again. What we have been doing in the first order circuits, what we have done, we said what it is. We said we found the mathematical model, which is the state equation. It's going to be first order differential equation. There's a special name for it. It is called state equation. We found that. And then we started to solve this equation, state equation. How we have done it, mathematical model, mathematical method is to find the homogeneous solution and then find the particular solution, add them up, we get the general solution. This is that one that we explained here. Circuit given to us. What is the circuit? Just I'll show you this circuit. Here you are. Let me clear this area. Pick I1 fast. This is the circuit given to us. So it is a first order circuit which has got an R element and a L element connected in serial. So the mathematical model for this circuit is this, we know that. Alright, dIL over dt, state equation, that is minus R over L ILT, that is function of t, of course, plus 1 over L Vs. And our source is a DC source, 100 volt. So this is what has been given to us. And I said in this we found the homogeneous solutions, find the particular solution, add them and find the general solution. Now I am going to explain this frame to you now. This frame is a special case. We are trying to find a particular solution, not based on the estimated function that we used here. We will be using an alternative calculation of this particular solution calculation. But this can be applied only in a special case. That special case tells us if the source is a DC source, then we can apply this one. So there is a special condition to be able to use that. So come back to this our circuit now. So this is the circuit given to us, and we will be calculating particular solution. So our aim is to find particular solution. Alternative, it's going to be alternative to what? Function estimation. So what is a particular solution? We've got to remember this. Particular solution is a solution in the form of the sources. If the sources are DC, in our special case, that is the DC source. DC source, special case. So particular solution is a solution in the form of DC source which validates these differential equations. So in the estimated function we were estimating a constant and phi ILT from that constant for this constant. In here we're going to do something different. How we're going to do it? We're going to use the definition relation of these elements. So our particular solution, we know that ILT is going to be a constant. I know that. Why is that? Because particular solution is a solution in the form of independent source. independent source DC, so this is going to be a DC. So it is true for all state variables. So in our case, state variable is inductor current, so it's going to be a constant. That's particular, I should say that. So this information helps us to do some changes to the circuit. How we could do that? If you remember, the definition relation of an inductor is this. If we say that IL is constant, so derivative of it is 0, multiplied with L gives you that 0. So this becomes 0. 0 means short circuit. So voltage is 0 is short circuit. Short circuit, we know that short circuit, let me show it on this different color here. When it is short circuit, that means it is connected like that. So the voltage is 0, so the current passing through is this current, which is the inductor current, isn't it? That current. So that means that short circuit current, ISC then, is also my particular source in this circuit. So we can easily say that what this IS, this I is also equal to ISC. That is C, not L. ISC short circuit, and that is I equal to I, and then I is also equal to that particular solution. So since this voltage is 0, so the voltage of the resistance becomes Vs, which is 100, over R gives the current of this resistor. This resistor current is equal to this one, so I can say that IL particular is equal Vs over R equal 100 over 10 to the power 3. That is 1K, that's why 10 to the power 3. This gives us 0.1 amp. That's our particular solution. So we can check it. So we could do it right now. That's the particular solution we found, and we found it without estimating a function. We have done it in a different way. So we can compare our result with the previous calculation method we used here. In here, we found I particular is equal to 0 to 1, and in here, we've done it by using the short circuit and get the same result. So that's the end of this video.